Hello, and welcome to the Esri GeoDev webinar series. This webinar is a continuation of the series we created in the hopes of engaging in developer-related topics and discussions in between dev summits. We have our developer summit coming up March 5th through 8th, and we would love to have conversations like these taking place throughout the year so that when we do meet in March, it will be as though we never stopped. We hope you get as much or more out of this webinar than you anticipated. Now, we would like to introduce you to today's webinar, ArcGIS Runtime and Kotlin. Before we get started, I'd like to go over a few items so you know how to participate in today's event. We've taken a screenshot of an example of the attendee interface. You should see something that looks like this on your own computer desktop in the upper right corner. You're listening in using your computer speaker system by default. If you would prefer to join over the phone, just select Use Telephone in the audio pane and the dial-in information will be displayed. You'll have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentation. I would now like to introduce Tyler Schiewe, Product Engineer for the Runtime SDK for Java. Tyler, let's get started, shall we?
All right, thanks, Amy, and hello, everyone. As Amy said, my name is Tyler Schiewe, and I'm a product engineer on the Runtime SDK for Java. I've been with Esri for almost 3 years now, and I'm currently based in the Portland, Oregon office. And for the last year and a half or so, I've been kind of an internal advocate for the Kotlin programming language within the Runtime team. So it's really a privilege to get this opportunity to talk to you about it today. So on my agenda, the first item is to go over a few slides giving a general overview of Kotlin. And then for about half the webinar, I'm going to go through some code examples that demonstrate some of Kotlin's features. And then for the second half of the webinar, I'm going to be demonstrating a mobile app built with Kotlin and the Runtime SDK for Android, as well as a desktop app built with Kotlin and the Runtime SDK for Java, plus a Kotlin library called TornadoFX. So what is Kotlin? So first, it's a general purpose programming language. And I start with this to answer the question of what does Kotlin have to do with GIS? Well, it doesn't have anything specifically to do with GIS. It only comes into play when you want to create applications that leverage a GIS or form a part of a GIS. In this case, you can use Kotlin alongside our Runtime SDKs to create applications that leverage the ArcGIS platform. First and foremost, Kotlin is an object-oriented programming language, just like Java, except it also has some functional constructs. And while this isn't unique to Kotlin, it does make it stand out from Java. And it's interesting to see its take on blending the two paradigms of object-oriented programming and functional programming. Kotlin is also statically typed, just like Java. And then I also want to note that as of Google I/O 2017, Kotlin is a first-class language for Android development. So who develops Kotlin? So JetBrains is the company that started Kotlin, and you probably know them as the creators of the IntelliJ IDEA and Android Studio IDEs. But there's also a large external community of developers called contributors that contribute libraries, frameworks, and tooling to the language. And the best thing is that you can contribute to the language too because it's open source. So where can I use Kotlin? So a really great feature is that pure Kotlin can be compiled to multiple platforms. So you can compile it to bytecode for running on the JVM and Android, and that's the focus of today's talk. But you can also compile to JavaScript. And there's even a way to compile pure Kotlin into native code. I wouldn't recommend using this in production quite yet because the API isn't stable, but you can definitely try that out. And then there's also a cross-platform story when it comes to Kotlin, where you can create pure Kotlin common modules that can be shared on projects for targeting all of these different platforms. Now, I won't be demonstrating this in today's webinar, but if you are more interested in this, I advise you to search Kotlin multi-platform. Now, this graph over here shows where Kotlin is being used. You'll see that mobile is the leader here due to Android, but there's also a healthy representation from backend servers, web front ends, and desktop as well. And I think this is a good indicator of how well the language is doing, considering it only reached 1.0 in 2016. Okay, so why Kotlin? Well, if you ask JetBrains, the first thing that they're going to say is because it's pragmatic. So Kotlin isn't some new, shiny, esoteric language from academia. Actually, there's hardly anything new about Kotlin. Most of its features are borrowed from other languages. Kotlin looks like a lot like Java, but you'll see ideas from Scala, C#, and Swift in Kotlin. It's also interoperable. So JetBrains' own products are written in Java and JavaScript. So they didn't really want to create a brand new language that they'd have to rewrite all their products in. Instead, they wanted a language that could work with those existing languages. So Kotlin is 100% interoperable with Java. That means that you can use all of the existing libraries of the Java ecosystem in your Kotlin apps, and vice versa. You can use Kotlin code and Kotlin libraries in your Java projects. And the same thing goes for JavaScript if you're targeting JavaScript. Next, it's readable. So Kotlin took all of the boilerplate code that you might write in Java that the compiler could do for you and removed it. And this makes the language more concise. And the functional aspects of Kotlin actually can make it more expressive. And it's this combination of being concise and expressive that makes it readable. And we'll see some examples of that a little later. And lastly, it's safe. So I mentioned Kotlin is statically typed, and that helps catch a lot of bugs before they appear at runtime. And it also has null safety. So you can avoid that dreaded null pointer exception from Java. Okay, so I took a little bit of time there with the slides to give you an overview. I hope that helped for those of you who have maybe never heard of Kotlin. Now I want to jump over to my IDE and show some demos. Okay, so I have 12 demos for you. The first half are going to show different Kotlin features that also have an equivalent with Java, so you can see Kotlin's take on those. And then the second half will show features that are only relevant for Kotlin. Our first example is the Hello World program, of course. And from a Java developer's point of view, this should look fairly familiar. And if you haven't seen Hello World in Java, I have it here in the comments. Now, the public main method is the entry point to any Java application, and that's the exact same in Kotlin. Now, I want to point out some of the differences, though. The first thing you'll notice is that you don't need to wrap the main method in a class like you do in Java. That's because Kotlin has top-level functions, which are kind of called like static functions in Java, which is why we don't have to use the static keyword. Also, we don't have the public keyword because everything in Kotlin is public by default. We also don't have void in Kotlin. Instead, this function returns an object called unit. And we'll go into why that is a little bit later. You can declare types of variables and the function using this colon syntax, which is a little bit different than Java, but you might have seen that in other languages. Another difference is that print line is imported by default since we use it so often, and we didn't want to type out the whole system out print line thing all the time. And then another big win here is we don't have to have semicolons after every expression. So it makes it a tiny bit more readable. Okay, let's talk about types. So in Java, we have primitive types like int or string or long. And then there's also object types in Java that basically coincide with those primitive types. And the object types have different methods on them, while the primitive types do not. So sometimes you have to convert between the two if you want to do certain logic. Kotlin doesn't have primitive types. Instead, it only has the object types, but you can still create these object types using the literal value. Another thing that I want to point out is that if I hover over this type declaration, you'll see that it's telling me that it's redundant. So I can actually remove this. And that's because Kotlin has type inference. So whenever the compiler can figure out what the type is, you can omit that type declaration. And for the most part, that's almost all the time. So that makes for a little less boilerplate code. Now for arrays, there's no special array syntax like there is in Java. Instead, arrays are represented just like objects with a generic type. And then there's also functions from the standard library of Kotlin that can create those. The other thing I want to point out is the var and val keywords. So var creates a mutable variable, just like a normal variable in Java. And then val is just like Java's final keyword. It creates an immutable variable, so you can only set the value once. Now, the really only difference between val and final is that for Kotlin, you have to explicitly declare either var or val. So you don't have the possibility of accidentally omitting final. And it's this small default that kind of pushes Kotlin developers to default to val, which is a good practice because immutable data is generally easier to reason about in programs. Okay, so next I want to talk about control flow. So here we have an if statement, and it looks exactly like Java. If it works, Kotlin doesn't get rid of it. Now things change a little bit when you want to return a value from an if statement. So Java has a ternary operator for this. Basically, you can give one condition and then have a return value depending on whether the condition is true or false. But that kind of breaks down when you have a few more branches in your if condition. It becomes somewhat, at least unreadable when you nest those ternary operators. So instead, Kotlin doesn't have a ternary operator. You can instead just return directly from a regular if statement, no matter how many branches it has. And so if you look here, the last value in between the braces of one of these branches is the return value. So that will be set to this temp variable. And Kotlin's type inference is smart enough to know that because each branch returns a string type, then the type of this temp variable should be a string. Okay, so that's if statements. For loops are very similar to Java as well. So here I'm taking a list of the numbers 0 through 10 and adding them to another list. And in Kotlin, I have this nice range operator to make this slightly more concise. Now this still has the same power as a regular for loop in Java. You can change the step size and so on. I'm just not demonstrating this here. The other thing I want to talk about is that I've explicitly used this mutable list. That's because if I switch to the default list, you'll notice I no longer have the add method. And that's because the default list is immutable. And again, this is another way that Kotlin kind of promotes using immutable data structures. You have to opt in to using mutable data structures because they're a little more complex. And just like Java, you can loop through different iterables using this in syntax. And that's because in Java, you do this with a colon, but that colon syntax is for indicating types. Okay, so that's regular control flow there. Now you'll notice in the last example that I didn't talk about a switch statement, and that's because Kotlin doesn't have a switch statement. Instead, it has an expression called when, which is like a switch, but with superpowers. In this case, I am creating a random variable, which is a whole number between 0 and 100. And then in this one expression, I have conditions on the left and then return values on the right. So when this random number goes through here, the first condition that it matches, the value on the right will be returned and then set to the variable grade. And now the only thing that all of these return values have in common is that they all extend the top type in the Kotlin type system, which is called any, which is equivalent to Java's object type. And then I also want to note that you can add an else case here. And we need that in this case because we're setting a value. So if none of these conditions pass, we'd still need a way to initialize this variable. So that's why we have else. I want to note that a Java switch doesn't work here. You'd have to use an if else branch statement because a Java switch can't check against conditions. So here's another example of where a when expression can take an argument. So in this case, you can take, basically you're comparing the value of grade to the different values on the left. You can check against literal values. You can say for any that are in this list, do the thing on the right. And you can also check against types. So you can say if this grade is an exception, like it went through this case, then I can actually use that exception. Now notice I don't have to explicitly cast this again to an exception like I would in Java. Kotlin can smart cast this to an exception so that I can directly access message. Now I don't need an else case here because I'm not setting a variable. So if grade does not match any of these, it just continues through. Some other things I want to point out is that this can even take null values, whereas a switch would throw a null pointer. And the other difference is that a switch can only compare against values of the same type. So it's pretty limited in that respect. So the when expression is a much better form of switch, and it's super powerful while being extremely concise in its syntax. Okay, so this is an object-oriented programming language after all, so we should be able to make classes, right? So this is how you declare a class in Kotlin. First thing I want to note here is that all classes in Kotlin are final by default. And you actually have to explicitly use this open modifier if you want to make it extendable. So that's a good thing to know when you're creating libraries. Now, you'll notice that this is a bit different than a Java class declaration. Usually you'd have just the line declaring the class name, and then you'd have a primary constructor down here in the body. Instead, it's moved up into the declaration. And that allows you to basically at a glance at the top line know kind of the minimum structure of this class. And you can do a lot in here. By indicating val or var on these arguments, you're actually stating that they're properties of this current class. So making a val property will be read only. It will not have a setter. And then vars can be gettable and settable. But you can also add access modifiers like private and protected to further restrict the visibility of those properties. So this is the primary constructor and the class definition all in one. Now, if you want to do any initialization of an object made with this class after construction, you can use the init block. And for any secondary constructors that you might want to use, you can use the constructor keyword, which has to explicitly reference the primary constructor of the class. Usually in Java, you'd have to call this within the first line of the body, but this is slightly more explicit. Now here I'm giving an example of an overload constructor, but we'll actually see later that Kotlin has a way where you don't need to even make these. But this is still just in case you want to make secondary constructors for some reason. If you want to make static properties of this class, then you put them in a companion object. Now, a object this keyword can also be used to create singletons in Kotlin. So a companion object is basically the object singleton representing the car class itself. So it makes sense to put static properties in there in this singleton representing the car. And then if you want to override methods, in this case the toString method on any, you can use this override keyword, which is a little bit more explicit than Java's override annotation. And then you declare the type just like a normal function. And then I'm also showing here some string interpolation, which is a nice feature of Kotlin, where you don't have to add together pieces of strings anymore. You can just kind of inject the values of variables into that string. Now, if I create an instance of this class, notice I don't need a new keyword and still no semicolon. So again, cutting down on small boilerplate there. And I can access those fields as properties because they are properties in Kotlin. So I can grab that val property that's read-only. I can also set the settable properties just like this, and then I can access static properties just like I would in Java using the class name. Okay, so that's classes. So you notice in that example, in representing a car, that class really only held some data, and it didn't have any complex logic in it. So in Java, we'd probably describe that using a Java bean. And this is what a typical Java bean looks like. You have your class declaration with some fields. You have a primary constructor that takes arguments and initialize those fields. You have getters and setters, and then you usually provide overrides implementing the equals hash code and toString methods of the object type in Java. And this is a lot of code just to describe a simple class that only holds data for two fields, right? So that's kind of why Java gets criticized for its verbosity. But we all know that most of us don't write this code ourselves. Instead, we have smart IDEs like IntelliJ IDEA that can generate this code for us just based on these two lines. But I have to ask, how do you know that this is the auto-generated code? In order to know that, you have to scan the whole class and make sure no one put any custom logic in there. And basically using this auto-generated code and having to put all this code in here, that's what we call boilerplate code. And so IntelliJ IDEA or JetBrains, being the company that created the IDE that generates this code for you, they thought in their language, the language should handle this for you. So the Kotlin version of a Java bean looks just like this. It's a one-liner. By using this data modifier on this class, that's telling me that I now have auto-generated equals hash code and toString methods that have sensible default implementations. Now, if I want to override some of those auto-generated implementations, for example, if I wanted to override toString and change what that would be, I can still do that. But still, at a glance, I would know exactly what methods are auto-generated and which ones have custom logic. So it's a little easier when you're adding new fields or removing fields from a class. You know exactly what's changing, and you don't have to worry about auto-generated code needing to change as well. So if I go ahead and print this, I can just show you kind of the sensible default implementation that a data class gives you. Ready soon. And this is the default toString. And this works on nested structures as well, and gives you a pretty nice readout of all the properties. So those are pretty nice, cuts down on a lot of boilerplate. Next thing I want to talk about is null safety, which we mentioned earlier. So this is a really powerful feature in Kotlin. So notice in this class declaration, I have some properties that have this question mark syntax at the end of the type. So that indicates a nullable type. Basically, I'm saying that I can create an employee and they must have a name, but they might not necessarily have an email or a car. So I can put null in for these values. Now, if I want to print the length of that email string, then you'll notice I get a compiler error. And that's basically saying that length is only defined on a non-nullable string. There's no way I can compute that on a null string. So instead of a warning for Java, we actually get a compile error in Kotlin, which helps avoid that null pointer. Now, one way that we'd get around that in Java is we'd first check if it's not null. But in this case, we'll see that we still get an error in Kotlin. And this wouldn't even produce a warning in Java. But Kotlin is smart because it knows that because this is a mutable property in a multi-threaded application, it's possible that this email could have changed to null right after we checked that it wasn't not null, or that it wasn't null. So we have to do something a little bit different. So one way we can do that is by saving that employee email to a immutable value. So notice that it has that same nullable string type, but if I check if it's not null, then Kotlin can use that smart casting like we saw in the when expression to now turn it into a regular non-null string. And now we can print the length of that email. Now this is still somewhat kind of boilerplate code, and these get kind of chaotic when you have nested structures like that. So we can do a little better in Kotlin, and that's where the safe operator comes in. So this question mark dot syntax means that if employee.email is null, then stop here and return the whole expression as null. So this will print will print the string null. If it's not null, then continue through and evaluate the expression to the length of that email and print that. And this really shines when you have to chain these. So in this structure, we can get the car, which may be null. And then we want to get the model and then print the length of that model string. Now, if any of the nested objects within evaluate to null, then we stop, evaluate the whole expression to null and print that out. Otherwise, we can continue all the way through and print out the length. So we're avoiding null pointers here and diving really deep into possibly null values without having to nest many if expressions. And most of the time, you don't want to just print out null if this whole thing comes out to null. So there's also the Elvis operator, which allows us to say, if this is not null, go ahead and evaluate to it and print it. Otherwise, if it's null, then use this alternative value. So that's null safety, and it's super powerful, and null pointer exceptions are by far the biggest exception that you're going to run into. And if you're smart about using this in Kotlin, you'll never run into them. Next thing really quick is optional arguments. So in Kotlin, in functions and in class declarations, arguments can be given default types. So this cuts down on redundant overload constructors like I showed before. You don't even need those because you can just use the default values. So here I can create a point passing in no arguments, and it will just have those default values here. Or I can pass in a subset of those values and use the default values for the remaining arguments. And another cool feature of Kotlin is that I can use named arguments to set a specific argument and then use by name and then use the default arguments for the others. So that's not even something you can do with Java at all. Okay, so now I want to talk about more of the functional aspects of Kotlin, and this gets a little bit crazier than what we're normally used to in Java. So here I'm creating an extension function. So extension functions allow us to add functions to classes that we didn't even author. So we're giving them new behavior. So in this case, I'm defining a swap ends function on a generic list type that's going to return a new list of that same type with the end swapped. So in the implementation, I'm first checking if it's empty or size equals 1. And if that's the case, then I just want to return the original list, which I can refer to with this. Otherwise, I want to create a mutable copy of that list and then switch the ends and return that. So that's my implementation. Now, if I have a list of strings, I can actually use that method, even though it doesn't exist on the regular list type. I've actually defined new behavior for it. Now, if you use this from Java when you're using Kotlin code with that interoperability, this function is actually a static function, and it looks like this in Java. So I can define that static function to be in a class called listUtils using this annotation. And then I would call this new method just like this. It's a static method on listUtils, and I'd actually pass in that list as an argument instead of calling the function directly on that type. So that's how it works from Java. The other thing I want to show is that in this example, I have an extension function on an integer, which takes another integer and then returns the sum of those two. And notice I can omit the braces if it's a single expression, just to make it a little more readable. And that would allow me to do something like this, which we've already shown. But if I add this infix modifier, then I get something a little more interesting, which is this syntax. I don't need the dot or the parentheses, and this can create some APIs which have a little more readable syntax, kind of like natural language. Now, you can only really use these from Kotlin. If you use this from Java, you'd still see this. But for Kotlin programs, it's a nice way to create a little more readable syntax. Okay, next I want to talk about higher order functions. So in Kotlin, we have higher order functions, which means you can pass functions into functions. Now here I have a inventory, basically a map of strings to integers, again using that infix function. And I want to look at this at the type declaration of this map function. So if we go in here, we'll see that the argument is actually a function type, and that's indicated like this. We have the argument on the left and then the return value on the right. So this actually indicates a function that we're passing in. And the argument type is map entry, and then the return type is just some any return type we want, and we'll get a list back. So if we want to pass in a function, we can actually do that using a lambda syntax, which you might be familiar with Java 8. Now, there's also, so we'll see that in this lambda, the argument here is that map entry, which follows the type definition we saw in the map function. And then we chose to return this as a string. So we're basically mapping a map entry into a string. Now, there's a nice kind of syntactic sugar from Kotlin that allows me to omit these parentheses if the last argument of this function is a function. Then I can just omit those parentheses and I get this nice clean syntax, kind of like a closure there. Last thing is if there's just a single argument, in a Lambda that you're passing in, you actually don't need an explicit name for it. Instead, you can just refer to it as it. Okay. Two more examples. Receiver type functions. So these are pretty interesting and a little complex, but we'll try to understand what's going on here. So I'm basically creating an instance of this class which doesn't, which has a constructor that doesn't take any arguments, that has a lot of properties. So I can actually create an object using that default empty constructor, and then I'm calling this apply function. And notice I can kind of set values of the variables in this class, and then I'm returning all of that back into the JSON variable. So let's look at what's going on in this apply function. So here I have another function type argument. So it makes sense I can pass in a Lambda, but there's this interesting syntax where I have a type dot and then parentheses. Basically, this is called a receiver type function. And essentially it means that you can pass in a Lambda and it's going to kind of inherit the scope of the type that you're calling it on. So in this case, this in the Lambda actually refers to an object with the same type JSON. So I can go ahead and do anything this Lambda that I would normally do to a JSON object. And then all of these are going to happen to an object and get returned back into this variable. They're kind of all applied at once. And then if I print out this pretty print on variable on JSON, then we'll see it's true. And whereas the default was false, this value was actually applied to this object and returned here. So I know this is kind of complex to see for the first time, but I actually have an example with the Android app that shows a real example of where this can come into play. The last example I want to give is a really interesting concept, and these are called type safe builders. So if you combine extension functions and these receiver type functions, you can actually make this really interesting syntax called type safe builders that can represent DSLs or domain specific languages. So in this case, I'm creating in this kind of funky syntax that looks a lot like Groovy from your Gradle build scripts. I am modeling an HTML document. And this is all using those extension functions and receiver type functions to basically, it's kind of like this apply, but deeply nested. And it can all build up into an HTML document. And I can even use other Kotlin code iterating through this. And it's kind of a way to mix code with a markup structure. So now you have a Turing complete language like Kotlin interacting with a kind of markup syntax. And that can be used to create really dynamic documents. Now, I have the implementation down here, but I won't go into too much detail for the sake of time. But if you want to know more about this, feel free to ask in the questions section. Now, one other thing I want to mention is that this doesn't have to just represent HTML. It could also represent any domain, such as a SQL query or maybe a map. And so I'll actually show another example of using this to build a UI in the desktop app example. Okay, so now I'm going to switch out of the examples and I'm going to go to my Android app. So here is the app running. It's fairly basic. I have a map with a light gray canvas base map, and then I have a layer depicting US congressional districts by political party. And I also have a custom label definition here that uses the name of the representative and then the district number, and also colors it depending on that political party. So let's go ahead and jump into Android Studio and see how I made that. So in my Gradle build script, you'll notice that I now apply the Kotlin Android plugin. So this allows me to create Android applications with Kotlin. And you'll see in the dependencies, we're using the ArcGIS Runtime SDK for Android dependency, which is a Java library. So now I finally get to demonstrate real interoperability from Kotlin with a Java library. So if I go to the main activity, you'll see that it's fairly simple. It looks a lot like a Java main activity. Here's how I would extend this app compat activity. That's what the syntax is saying. And then I'm overriding on create just like I normally do in a Java app. And this is where I'm initializing my map. So notice that I don't have that new keyword. And so this is coming from a Java library, but the syntax looks like it was just coming from a Kotlin library. You can't tell the difference really. Now this map view is coming from my layout XML file. And I'm setting the map to it. And then I'm creating a service feature table, which uses the URL to features of those congressional districts. And then I can create a feature layer from that. And using that property syntax, I can add that feature layer to my map's operational layers. Now here I can add a callback on the feature layer to listen for when it's done loading. And I can actually use that Lambda syntax that I was talking about before. Since in earlier versions of Android before Java 8, you would usually have to pass in some kind of like anonymous class instance and then have it override like runnable or something like that. And it would be a very verbose syntax. In Kotlin, this existed before Android got Java 8. So it was way cooler back then, maybe not as cool now, but you can have this very concise syntax with callbacks. Basically what I'm doing in this callback is that if the feature layer loads successfully, then I'm going to set the viewpoint on the map to zoom into it. Otherwise, I'm going to show an error message. Now, I also want to show how we created those custom symbols for doing those custom labels. And here, I'm actually showing a real example of using this apply. So text symbol has quite a few properties on it, and we didn't want to define constructors for every single variety of those properties. And especially since this is Java, it's not like we could define all those default values fairly easily like we can do in Kotlin. So instead, we can use apply and then set all of those properties that we want on the text symbol, and then we'll have a text symbol in this variable that has all these things applied. So I do the same for Republican districts and Democratic districts, making those symbols there. And I'm also using this in creating a JSON object, which forms our custom label definition. And with this, in Java, you might have like multiple lines where you say JSON definition dot add this, JSON definition dot add symbol, and just very repetitive. In this case, we kind of see the nested structure of the JSON by using this apply syntax. So it's a little more readable there. So I'm creating those custom definitions based on the party type. And then I can create label definitions from that JSON and add those to the feature layer and set them enabled. And that's all it takes to create that little app. So pretty nice that we can use already today our existing Java library for the Runtime SDK in a Kotlin app. Okay, so now we're going to transition over to a desktop app. And I'm going to run this real quick so that you can see how it looks and what we're going to build. Shouldn't take very long here. So in this case, we actually have a 3D scene rendering, and we have this view shed, which allows us to do some analysis on what would be visible from a certain vantage point. And it interacts with the buildings in real time, so that's pretty nice. But we also have all these UI controls and kind of this complex UI where all these controls are bound to properties of this view shed, so I can interact with it. Now, let's go back and see how we created this. So again, I'm going to start with the Gradle build script. Here I'm using the Gradle plugin that we have for the Runtime SDK for Java to add that dependency. And I'm also using the Kotlin plugin to enable Kotlin in my Gradle app. Now, the Runtime SDK for Java uses Java effects to render UIs on desktop platforms. But there's another library that's written in pure Kotlin that builds a DSL on top of Java effects. And so it's a very idiomatic API for Kotlin for building UIs. Now, first I'll start with the app declaration. Here I have an app which is just like a Java effects application. And I can pass in a class representing the main view for my app. And I can also pass in styles for a custom style sheet. Another interesting feature is that I can find a view by the class name and then use that. In this case, I'm disposing of extra graphics resources from my scene view on the app stop. Now let's look at the style sheet real quick. So this is kind of interesting because this is actually creating CSS, which normally in a Java effects application, you would style your UI using CSS. But we're using a DSL to build a type-safe CSS syntax. So you could actually make this dynamic and dynamically change your theme of your UI at runtime in a type-safe way instead of passing around static CSS style sheets. So that's pretty cool. That's a real case of DSLs being used. Okay, so if we go back to the app and check out the main view. So we can actually have UI components described by this view class in Tornado FX. So here I'm initializing my 3D scene, similar to how I did with the map, and putting this into a scene view so I can render it. I'm adding elevation data and that building scene layer, and then creating an analysis overlay to hold that view shed that I'm going to operate on later. Setting the camera position to look at the view shed. And then I'm creating another view using that view shed so I can bind all those sliders based on that view shed. So if we go into control panel, we'll actually see how we built that little control pane UI in another DSL, which in Java FX, you can use FXML, which is a XML markup language, similar to how you'd define a layout in Android. But that markup file is somewhat static. You have to bind that to a controller in Java code in order to do any dynamic work. Here instead, you can combine Kotlin code right into the markup type language with this DSL syntax. So here I have a grid, and every row in that little UI with the controls, I can create a row, then I can label it, and I can create a button whose text is based on a viewshed property that's passed in. And then I can bind the selected property of the button and add a listener, again with the Lambda syntax, all of the features that Kotlin provides. to update the properties of that viewshed. So here I've created really a UI component, which is a slightly different paradigm than like model view controller in regular JavaFX. And so this is an example of just how you can use Kotlin libraries with nice DSLs to build a really Kotlin idiomatic way of building UIs. Okay, so that's my demo there. Now I hope that has been helpful in understanding Kotlin and getting a feel for the language and how you can use it today with the ArcGIS Runtime SDKs. Now, if you're asking how do I learn more, these are the resources that I'd recommend for you. There is a Coursera course. This is done by the designers of the language, so you can't go wrong there. You can try out Kotlin on an online sandbox. You can try Kotlin directly from your IDE with the EDU tools plugin. And that will provide examples very similar to how I showed my examples today. If you like webinars, then JetBrains provides some webinars on Kotlin as well. And then there's some great talks on YouTube, which is personally how I learned about Kotlin in the first place. And with that, I thank you for your attention, and I'm going to turn it back to Amy to facilitate questions.
Thank you, Tyler. We're now going to begin opening up the floor to answer any questions that are submitted for today's presentation. If you have any questions, feel free to submit them in the questions pane, and Tyler would be happy to answer them or address them. It doesn't seem that we have very many today, Tyler, so you may have actually answered everybody's questions.
Wow, awesome.
Surprisingly. So in this case, what we would do then is we would thank you very much for your time. And if you do have any follow-up questions, you're always welcome to send me an email. There should be a follow-up email that comes to you and as well as a survey. So you can definitely fill that out and ask any questions by responding to the email there. And that'll come directly to me and I can get those questions answered for you. We did have a couple of questions that came in while I was talking. One is, are there any DSLs around the SDK for Kotlin?
So currently there aren't any. That is something that's interesting to us. The nice thing about these DSLs is because Kotlin is 100% interoperable with Java, you can actually write a DSL around it right now using those extension functions. So even though you don't author our SDK, you can still add that kind of behavior to our types on top. So it's fairly easy to create a wrapper DSL around an existing library that doesn't already provide one. But if you are interested in that, please follow up with us and we'd be interested in pursuing that opportunity.
All right, we had another question wondering if you are able to share the code that you presented today.
Absolutely. Right now it's in a private GitHub repo, but I will make that public right away.
Yeah, and what you can do, Tyler, is once you have that, you can send me the URL and I'll post that as part of the GeoNet blog post that we produce under the Geo Developers group in GeoNet. So if you are interested in following up with that, you can receive it there. We have another question. How can we use Kotlin to create web applications using Esri JavaScript API?
That's an interesting question. So, so you can use, or you should at least be able to use JavaScript or ArcGIS Runtime's JavaScript library within a Kotlin application. Now, I don't have any examples to show offhand, but you can still actually use Gradle to basically fetch using a Kotlin JavaScript plugin to fetch JavaScript dependencies. So you list the ArcGIS Runtime SDK for JavaScript as a dependency there, and then you can call that directly from Kotlin. And if you want to know more about that, I'd advise that you look up the documentation on Kotlin's website, and they'll be able to show you how to interact with other JavaScript libraries in a Kotlin web app.
Okay, great. Another question came in, is Kotlin going to replace some old languages?
I don't know about that. It certainly has gained a lot of popularity, but like I said before, the intention of creating Kotlin wasn't really to replace really useful languages like Java and JavaScript. I don't think those are going anywhere personally because their ecosystems are so big, and they're used so widely. Instead, it's used to interop with those languages. So I I'd have to know more about what old languages you're talking about. If you mean like Java, I don't think it's going to replace Java personally, but it certainly had a lot of Java developers move over to Kotlin because of its nice syntax and different features. But I still think Java will play a role for quite a while.
Okay, great. And how about migrating the code done in Kotlin to iOS? Do you have any suggestions on that?
Migrating code from Kotlin to iOS. So you definitely want to look into Kotlin native if you want to directly use a Kotlin library in an iOS application. That might be something that's possible. Or you can actually write, if you really wanted to, iOS apps in Kotlin and just compile that to native code. Now, if you actually just want to migrate in terms of just converting between the two languages, Swift and Kotlin are actually very similar. So it should be fairly easy to reason about how you should do that translation. I'd have to know a little more information about your specific case to give more detail on that, but I hope that helped.
Great. And I see finally we have where can they find that 3D demo that you showed? Would that also be accessible on the GitHub repo?
Yep, all the examples will be in that same GitHub repo.
All right, wonderful. So thank you very much, Tyler, and thank you everyone for attending today's webinar, ArcGIS Runtime in Kotlin. If you have any other questions, like I said, please feel free to contact me using my email address and your follow-up email that comes to you after this webinar. Once you leave today's webinar, like I mentioned before, you will receive a survey on the presentation, and we would definitely appreciate if you can complete that and provide your feedback. We will be providing a recording of this presentation, and it will be available within 7 to 10 business days on the go.esri.com/geodev page, more specifically on the ArcGIS Runtime and Kotlin registration page that you accessed earlier. It will turn into a recording that you can then see. On behalf of Esri and our presenters, thank you so much for joining us today, and thank you. Have a great rest of your day. Happy Halloween.